Alright, so this is from the version of the book that I have. You want to separate all of these out. So the first thing I'm going to do is go ahead and I'm going to add my ether, and I'm going to add water at a pH of 2. That's 2 points above these guys right here. And that's, way above these. The water layer, since we're so far above these are just going to stay like this. Oh, that's right, you guys did not see when I did that, so let's just get rid of that and that. And I will now add those back in really quick. Sorry about that. Okay, so our water layer is going to be the ones that already have the charges, right? They're going to dissolve as they are. So we're going to have this guy right here. And we're going to have another one, which is the other one that already has the charge, right? And go back to drawing. NH3 plus. So if we do this, we know it's not going to accept any more protons. So these two are going to dissolve in water. Everything else is going to go into your ether layer. So we have this bad boy right here. Need to shape. And I need to shape. How many do we have to have? 3? That was really bad. Alright, whatever. That's good enough for me. So we've got these two guys right here in the water layer, and we've got the other 3 in the ether layer. So HOOC, got these, and then we have our OH minus. There's more than one way to do these as well, guys, just so you know. This is just one approach. Okay, so since these are in the ether layer, I can adjust the pK. I can adjust the pH of this one right here, and when I do that, I can cause these to dissolve in the water, and then I can leave this in the ether. Once I have this in the ether by itself, I can boil it off. So what I will do with that then is I will take this I'm going to go ahead and mess with the water layer over here. And in doing that, I'm going to add some ether. And I will adjust the pH to between 7 and 8. 7 to 8. And with doing that, that's 2 points above this guy, right? And that is, what is that? 3 points below this one. So, since that's 2 points above this guy, this will go into the water layer. And then this will turn into NH2 and go into your ether layer. Once you have something by itself in the ether layer, it is totally okay to assume that you're able to go ahead and separate it. So because the ether boils at a really low temperature, so once it's by itself in the ether layer, you can go ahead and just boil off the ether and you have it by itself. Now that we have this and the pH is about 7 to 8, we can adjust the pH again to precipitate this out. And it's at what, 4? Yeah, 4 point something. So you would want this to be lower, if I'm remembering correctly. We adjusted this down, yeah. So we want to basically strip off this proton. So if we wanted to precipitate this guy out right here, we're going to have our pH equal to, what was our pKa? Our pKa was 10.66. So we'll go ahead and drop our our pH down to like, let's just say 13, 13, 14. You want it like super basic, so it'll rip off that last remaining proton, and that will give you this guy right here, which you now have isolated. It'll precipitate out. Now, coming back over to these guys, honestly, just doing more of these problems. If this still isn't helping you, just find more of the problems and do more of the problems. The more you do these, the easier they'll start to become. So, okay, we have this now. And what we're going to do is we're going to add water. So add H2O, and we're going to adjust the pH of that to anywhere between 7 to 8, so approximately 7 to 8. So that's pretty much just water, because water, if it's neutral, has a pH of 7, it might have a little tiny bit of sodium hydroxide, but not much. So that's because if you wanted to push it more towards 8. In doing that, our ether layer, I should probably write an ether layer over here. So ether is just going to contain this and this, because since we put the pH at 7 to 8, the pH here is going to need to be, this is the OH, here let me scroll up so you can see, it's going to need to be 11.95 or lower so we can strip off that proton. Here, putting it at 7 to 8, it would need to be 6.17 or lower, but 7 to 8, that's plenty low enough to pull off that proton. But it's not enough to pull off this one. So with that being said, if we go over to the water layer, we will have this guy, which will be COO minus, right? And it's going to be COO minus because we stripped off the proton by making the pH what we made it, because it needs to be 6 and below to strip off that proton. So if we wanted to take, and keep in mind every time I'm adding water, adding ether, I'm separating these into new funnels or whatever you want to put them into, beakers, whatever. To get this to finally precipitate, so we have it by itself, we're going to adjust the pH to 2 or higher. So pH approximately 2. It could be 2.17 or higher to get it back to the form that we would like it in, which is COOH. Okay, so now we have, oh, I didn't even draw this in, my bad, guys. Now that we have that, we are going to focus on this last layer right here, this ether layer. So if we want to take this ether layer and separate these two, we need to adjust the pH. We're going to add water, basically, and that water needs to be at a pH of about 11.95, so I'm just going to call it 12. So add H2O, add a pH of approximately 12. So again, we're going to have two layers because it's already in ether. Our ether layer is going to have that chlorobenzene, and then we'll be able to just boil off the ether, and that guy will be by itself. Our water layer will have this in it. Now, since it has this, if we want to precipitate that out, and then we can just vacuum filter it, or whatever we need to do, we can adjust the pH again, and we can adjust the pH to 2 points above this. So that would be, we can just add water. Basically, it would need to be 7.95 or higher. So we're going to put our pH at, we'll just say 7. It can be 6 to 7. So let's just write that 6 to 7. Basically, it just needs to be closer to 1 at 7 or closer to 1. So 7 or smaller, and that will give us, that will reprotonate our molecule and put us at this again. So we'll precipitate out. I hope this helped at least a little bit, guys. Let me know if you have questions over the weekend. Let me know as well. All right. Basically, if it has an extra proton, you want to drop the pH below 2 points below. So 2 points. Okay. If you have like NH3 plus, it's connected to some R, so some ring or something, like this guy right here. Our pKa on this one is 10.66. If you want to make that this, which means that it will no longer dissolve in water, we're going to want a pH of, well, technically 12.66 to 14, because 14, is like the lowest you can get. Or the most basic. If you have something like this, where you have that OH, so I'm talking about this guy basically, we know that its pKa is 9.95. We want to make it, if we want to dissolve it in water, we need the pH to be more basic than this pKa, so 2 points below, so 9, 10, 11.95. So it needs to be at least 11.95 to 14. 14 would be like way overdoing it, but it needs to be, this is the minimum it could be. And then if you want to turn around and reprotonate it, so to get it to go to this, again, you're going to adjust your pH to 2 points above this. So your pH needs to be anywhere from 7.95 to 1, and 1 is like way overdoing it, but I hope that at least this part right here made sense. If you're not given the pKa for something, like this one right here, you can just go ahead and assume it's going to dissolve in the ether, and you want to get it by itself in the ether. Okay? Like I said, I hope that helped. Just let me know. I'm going to upload this right away. So yeah, let me know if it helps. I'll send a message out on Remind right now.